In this video, we'll discuss about three-phase synchronous generator. Well, the first question is, what is generator? Generator is a machine which converts mechanical energy into electrical energy. So here we're discussing about AC generator. It has two different names apart from AC generator. The first one is called synchronous generator. The second one is called alternator. Why they are calling AC generator as an alternator and synchronous generator, we'll see in the upcoming slides. First of all, we'll see what mean by alternator. An alternator is an electrical generator that converts mechanical energy into electrical energy, that is in the form of alternating current. That's why AC generator is called alternator. Well, we'll see the construction details of this alternator or AC generator. Basically, it has two parts. The first part is called stator, second part is called rotor. A stator is nothing but it is a stationary part of the machine. Rotor is nothing but rotating part of the machine. Well, here we'll see stator. The stator have many parts here. This part is called lifting eye. But now we'll see that the outer part of the machine is called stator frame or steel frame, what they're saying here, and inner part is called stator core. Actually, stator frame is made up of mild steel plates, and the number of plates are welded together to form cylindrical structure like this. And inner part of this stator is called stator core. The stator core is made up of laminated silicon steel plates. Why they're using silicon steel plates means to reduce eddy current losses and hysteresis loss in the stator core. So we are using silicon steel plates, that is laminated. Then the inner periphery of the stator frame has number of slots. Here we can see that these are the various slots. These slots will carry armature winding. Here we can very clearly you can observe the stator frame, stator core, and slots is carrying number of conductor, that is what we can call armature conductor here. So the question is, what mean by winding? The winding is nothing but here the number of conductors arranged in particular form is called winding. Now we'll see rotor. As you know that rotor is rotating parts of the machine. Here two types of poles are available. The first pole is called salient pole. The salient means the poles are projecting out from the magnetic wheel. You can see here, this is the magnetic wheel. The poles are projecting out from the magnetic wheel, and these poles and the magnetic wheels are fitted together by using nut and bolts. Let us see some important features of the salient pole. The poles are projecting out from the magnetic wheel. The air gap is non-uniform. We can see that this is one pole, another pole. In between these two poles, again a huge air gap is there. So therefore, there is no uniform air gap. Mechanically weak because all these poles are projecting out and they're fitted together by using nut and bolts. Therefore, this machine, the salient pole is having mechanically weak construction. Prime mover used are water or inner combustion engines. This kind of poles are usually preferred for low and medium speed. So you can see here the speed ranges from 300 to 600 rpm. Here this is having large diameter and small axial length. This is axial length, small axial length, but it's having very large diameter. And this kind of poles are used for horizontal axis operation. Next one is non-salient pole. Here we can see that these poles are not projecting out from the magnetic wheel. We can see here very clearly, and in this diagram also. And the feature of non-salient pole is exactly opposite to salient pole type of rotor. First one, we will see that here it is having number of slots in the outer periphery of the magnetic field, and these slots will carry winding. These are called a field winding, and poles are not projecting out. The air gap is uniform. You can see that here the air gap is very uniform here, because the number of slots and all those things are very small, and the poles and another thing is the poles are not projecting out, hence the air gap is very uniform, and small diameter and large axial length. This is mechanically strong because no poles are projecting out from the magnetic wheel, and prime movers are steam turbines or electrical motors. For the same separating higher than salient pole type, this rotor is also called non-salient or non-projecting pole type, and this type of poles are preferred for very high speed. As you know, salient poles are preferred for low speed. Usually this is prefers for vertical operations, and salient poles is preferred for horizontal operation. Okay. Now see the principal operation of generator. Actually, AC generator works on electromagnetic induction. We'll understand this concept little bit here now. The moment when DC supply is connected, actually the range of the DC supply is 110 volts to 220 volts. It's connected to all field winding through carbon brushes. These are the carbon brushes, these are the slip rings. Well, the moment when DC supply is connected to the rotor, the field winding produces electromagnetic field. Well, so this electromagnetic field is constant because we are using DC supply. The moment when this rotor is started rotating with the help of any prime mover, the prime mover may be water turbines or steam engines, or it may be IC engines. The moment when the rotor starts rotating, here the conductors are stationary, the magnetic field is rotating. Due to the change of magnetic field linked with the conductor, EMF is generated according to the Faraday's law. This is a basic principle of operation of generator, and this kind of generator will produces 11 kV volt, or it might be odd multiple of 11 kV volts. Now we'll see frequency of generated voltage. To understand the concept of this, here I consider one conductor and two poles. Here we can see that this is a one complete cycle of EMF which is generated from the alternator, and this is causes due to the pole N, and the negative cycle causes due to the S pole. To understand this better way, let us look at that. To create one complete cycle, we required two number of poles. Therefore, the number of cycle of EMF induced in one revolution is P by 2. Then, to complete one cycle here, so the time required for this one is the number of revolution per second is N divided by 60, where N is indicate that speed of the rotor. Then F is the number of cycle per second. F means frequency. As you know that the frequency is nothing but number of cycles per second, that is equal to P divided by 2 into N divided by 60. So the frequency of generated voltage can be calculated by using the formula F is equal to Pn divided by 120. And the frequency in India, all AC devices works on the principle of 50 Hertz. So here, to get that 50 Hertz frequency, the number of poles are fixed, as you know already, and here we need to rotate the alternator with constant speed. Hence The AC generator or alternator is also called synchronous generator. Because of that, it is rotating with the constant speed to get frequency 50 Hz in India. But in other countries, the frequency may be 60 Hz also. Now, we'll see the EMF equation of generated EMF. First, we'll see Z is nothing but number of stator conductor. Here you can see that there is a n number of slots are available. The slots will carries number of conductors. That number of conductors is indicated by Z here. Then P is the number of poles. We can see that various poles are available. In this one we are using the red and blue color. The red color is usually treated as a N type of pole and the blue color is treated as a south pole. F is the frequency of induced EMF, that is in the hertz, that is 50 hertz frequency, and the flux is nothing but what are the flux produced by these poles the moment when DC supply is given to the rotor. Now we'll see that the flux cut by the conductor in one revolution. Here I am consider only one conductor. So the change of the flux is indicated by d pi, that is equal to P into pi, because P is that total number of poles here and pi is the flux produced by per pole. So therefore in one revolution the change of the flux is P into pi. Then time taken for one revolution, that is change of time is indicated as dt, that is equal to 60 divided by n. Then the average EMF induced in one conductor is equal to, that is the change of the flux divided by time according to Faraday's law, that is equal to P pi divided by 60 by n. So after simplifying this term, we'll get that P pi n divided by 60. Now the average induced EMF in one conductor, that is equal to d pi by dt is equal to P pi n divided by 60. Already we know that. So we know that from that generated frequency F is equal to Pn divided by 120. Let us represent this entire equation. N is equal to 120 F divided by P, and you will substitute this term in the above equation. After substituting, so we'll get that this term P pi divided by 60 into 120 F divided by P. After simplifying this term, so here 60 and 120, 61 ja 62 ja is 120. After simplifying, the average EMF induced in one conductor is nothing but 2F by Z. Actually, here we calculated average value, but it is a AC. AC is usually represented in RMS value. So therefore, we know the relation RMS and average value, that is nothing but 1.11. From that the various factors, peak factor, form factor, just it is for your recall. So ERMS divided by E average is equal to 1.11. Then the RMS induced per phase is equal to 1.11 into 2F by Z. After simplifying these terms, we'll get that 2.22 F by Z. Now, finally, the EMF induced per phase is 2.22 F by Z. Here I consider two different factors. The Kp is nothing but pitch factor and Kd is nothing but distribution factor. So here we'll not discuss more thing about Kp and Kd. Directly we'll utilize the property of Kp and Kd in the numerical. But these two are very essential to consider the generated EMF in the generator. Once again, I want to recollect that Kp is nothing but pitch factor and Kd is nothing but distribution factor. Well, thank you.